let's talk about solving equations by graphing. Now, a lot of times when you guys are given a set of equations and we say solve, we let you do whatever you want. Since we're only focusing on solving systems of linear equations, you guys are going to have to do by the methods that we tell you. You're going to have to graph sum, you're going to have to use substitution, and you're going to have to use elimination. You can use the other methods to check yourself, which is fine, but we want you to do the methods that we're asking you when we're asking you to. So when we talk about graphing, all right, let's put some notes over here for graphing. All right. A solution, write this, I am recording. A solution is the intersection point. What does that mean? What does it mean if there's an intersection of two lines? It's where they meet, it's where they cross, okay? So you'll have problems that when you graph, looks like this, and where they meet is their solution. And you write that solution as an ordered pair. As an ordered pair. What do I mean by ordered pair? X, comma, Y. All right, you just circle your answer. You're not going to get credit for it. You have to write it as an ordered pair. Now, there's different kinds of solutions, and we're going to go through those different kinds of solutions. When you have two lines that intersect right here, right? That is their solution. You would say here that there's exactly one solution. What that means is you take that x and y and you plug it into the system of equations, it would make both equations true. Where they intersect, that is the solution. You could have a possibility, guys, where you graph two lines and they look like this. Do those lines ever touch? If you have two lines that never meet, what would your answer be for that? Not infinity. Think about it. A solution is where they intersect. There's no solution here. Do these two lines ever touch? No. If you have two parallel lines, your answer would be no solution. Now, if you had something that looked like this, here's my one line. All right, everybody watch. Here's my second line that I graph. What do you notice about those two lines? The gray one and the purple one. What do you notice about both of those lines? They're where? You guys don't notice anything about the two lines I just graphed? They're right on top of each other. Those are called coinciding. This is when your answer would be infinite. Infinite many is what we say. What that means is any point along this line that you pick, any x and y, and you plug it into both equations, it'll make the equations true. So when the lines do not touch, that's when there's no solution. Because your solution is where they intersect. If they are right on top of each other, that means any point that you pick along that line will work, quote unquote work. It'll make the solution true or make the equations true. So that's when you have infinite. Everybody understand that, the differences? All right, so let's do some examples, all right? First of all, when we graph a line, we want our line to be in y equals mx plus b, right? M is what? The slope. What is b? The y-intercept. Good, very good. So you want to identify the slope and the y-intercept. Now, guys, I think it's a good idea because so many times when we graph a line, still as seniors in high school, we don't know which way the line is going to go. A positive line, right? A positive slope is going to go upwards. However you guys want to say it. I would draw yourself a little picture. If you have a negative slope, your line is going to go downwards. I'll show you what I mean by draw yourself a little picture. And I was doing that today with first period, and they were like, man, that really does make sense. So let's try that, okay? All right, so look at this first set of equations. It's already in y equals mx plus b, correct? So this is what I expect to see on your test when you guys are showing me work. All right, this first line, all I need you to see is that you tell me that 2 is the slope and that negative 3 is the y-intercept. And then on your graph, you're going to go, okay, at negative 3, I'm going to put my point, My slope is positive 2. If I were you, I would do a little line right here that just says, okay, my line's going to go upwards like that. So if my slope is 2, from this point, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Notability helps me out here when I draw my line, but whoops. Okay, just go with it, guys. That's the straightest line you've ever seen in your whole life. All right, the bottom line. What's my slope? -3. And what's my y-intercept? Okay, good. So I'm going to go to positive 2. And think about what my line should look like if it's negative. It should be going downwards. Give yourself that mental picture. So when you go from that point and you're going to go 3 over 1, you go down 3, 1, 2, 3. You're going to go to the right one. Then down 1, 2, 3, then over 1. And you connect those dots. I need to see both lines, not just where they meet. So there you guys have graphed both lines, and there is their solution. How do we have to write our solution? As a what? As an ordered pair. What is that ordered pair? Where do those two meet? At 1, comma what? -1. This is my x, this is my y. Algebraically, how can I check to make sure I did that problem right? I could plug it in. I could take +1, plug it into both x's. I could take -1, plug it into both y's, and it should make both equations true. If for some reason you went the wrong way or something like that, you can always check and say, oh wait, look, I made a mistake because when I plugged my solution in that I found, it didn't work. Everybody see that? Okay, let's go on to number 2. I just randomly did 9 today in first period, so I'm going to do the same, 9. All right, this is already in slope-intercept form. Fantastic. This makes my life easy. So I know my slope here is -5/3. It's negative, so it's going to be going downwards. And 1 is my y-intercept. So I'm going to go to +1. And remember, you want your line going downwards. So I'm going to go down 5. 1, 2, 3, 4. Whoops. 1, 2, 3, 4, 5. And over 3. 1, 2, 3. Up 5, 1, 2, 3, 4, 5, and over 3, 1, 2, 3. So about there-ish. We're going to connect our dots as straight as possible. And then my second equation, I know that this is my slope, -1/3, so it's going to go down. And I know that my intercept on the y-axis is -3. So I go to -3. And my slope is 1 over 3. So I'm going to go up 1 and over 3. Which way? So my intercept is, so I'm going to go up 1 and over 3. 1, 2, 3 over here. Then I'm going to go down 1 and over 3. 1, 2, 3 over here. And I'm going to connect my dots. Is there a solution to this system of equations? Is there a point where they intersect? Yes. What is that point? 3, -4. Now, a very common mistake. All right, I'm going to try and point this stuff out to you. Very easily, you guys could have put -4, 3. Just because you're not paying attention. I know everybody in here knows how to tell me how to get from the origin to that point where they meet. But if I said -4, 3, that just means you went down and then over. That's why it's important, because this concept is pretty easy and you guys are thinking, oh man, I'm so glad we're going to do this. Don't make silly mistakes. When you get to this point and you have to solve by graphing, take your ordered pair and just plug it in, just to make sure. If you make a silly mistake like -4, 3, you'll catch it there and then you won't get points taken off. So just make sure you guys are aware of that. Let's do number 3. I want to do number 3 for a specific reason. Why do you think I want to do number 3? All right, it's already it's already y equals mx plus b, but then what is that second one? X equals, we're like, wait, what? So let's look at this first one. My slope is -1, and my y-intercept is at +1. All right, so my line's going to go down because it's negative. So my intercept is at 1, and then I go down 1 over 1, down 1 over 1, down 1 over 1. I can go up 1 over 1, up 1 over 1. Connect your dots. It's a nice, pretty line. This second thing says x equals 3. Well, there's not a y or anything. How do I graph x equals 3? Where is x equals 3? On the x-axis or the y? Where's x equals 3? On the x-axis or the y-axis? It's on the x-axis. It's right there. So how would I draw a line that goes directly through the point x equals 3? A vertical line. Very good. So you have a vertical line. Is there a point where these two lines intersect? Yes. What is that point? 3, -2. And again, that's your x, that's your y. Plug it back in. So when you guys see just x equals, in your mind, what kind of a line should it be? Vertical. All right, we always make that mistake because we think, well, the x-axis goes left and right. But think about it. You want a line that goes through that point. The only way to draw a line through x equals a number would be a vertical line through that point. Good. All right, let's look at 7. Is 7 on this page? No. Go to the next page. Look at 7. 7 is similar. It's not the same. It's similar. How is it similar? It has the y equals. Hang on one sec. Okay, back to number 7. First one, easy. It's already in slope-intercept form for us. So what is my slope for this first equation? What's the slope? 4/3. Perfect, just like it looks. And it's a positive line, so it's going to go upwards. And the y-intercept is at -3. So I'm going to go to -3. And then I'm going to go up 4, 1, 2, 3, 4, and then over 1, 2, 3. Right? You guys agree? Okay, draw your line. Then I have y equals 1. Well, where is y equals 1? On what axis? The y. So I'm going to put a point right there. And if I draw a line that goes through that point, it's a what kind of a line? It's a horizontal line. So remember, when you have y equals, it's going to be a horizontal line. X equals vertical. What is the solution to this system of equations? 3, 1. And again, how can we check? Plug it back into each equation. All right. How are these ones different from what we were just doing? It's not in y equals mx plus b. Do we know how to get it? Absolutely. Let's look at the first one. Just rewrite the problem. X minus 4y equals -4. Remember, you're trying to get y by itself. So the first thing you're going to do is move the x. Then you're going to divide by what's in front of y every single time. So if I move the x over, I'm going to subtract x from both sides. So my x's cancel out. I have -4y equals, write the x first, so -x minus 4. And now what? Divide by -4. Now, guys, watch. Instead of doing a big division sign and just writing -4 once, I would go ahead and write it under every single term, just so you don't make any silly mistakes. I have y equals. What is a negative divided by a negative? Positive. What number is in front of x that I don't see? So this is the same as 1/4x. What's a negative divided by a negative? So this becomes +1. It's real easy to miss that, guys. This is a super easy concept that we can make a lot of mistakes on. So just make sure you're paying attention. Your slope here is 1/4, and your y-intercept is at 1, right? So go to 1, put a point. Remember, this is a positive line, so it should look like that. So I'm going to go up 1 and over 4. 1, 2, 3, 4. I'm going to go down 1 and over 4. 1, 2, 3, 4. Now, when we do this, guys, I'm not going to give you any. There's none on the practice, and there won't be any on the test that are like in the middle of a point. You can't tell if it's a half or a quarter. So if you get something that doesn't meet directly on a number, then you did something wrong. All right, let's look at the second one. My second equation here is 5x minus 4y equals 12. Again, we're trying to get y by itself, yes? So subtract 5x from both sides. So I have -4y equals -5x plus 12. It's a positive 12. You can't combine those two because one has an x, one doesn't. And now what? Divide by -4. Good. I'm going to divide each piece by -4 so I don't make any silly mistakes. So y equals, what's a negative divided by a negative? So I have 5 over 4x, right? What, then what? Minus 3, good. So my slope is going to be a positive 5 over 4. My line's going to go upwards. And then my y-intercept is at negative 3. So I go here, negative 3, up 5, 1, 2, 3, 4, 5 over 4, 1, 2, 3, 4. Works out nice and pretty. Straightest line y'all have ever seen your whole life. Where do these two lines meet? At 4, 2. Again, how do we check algebraically? You plug in your x and your y into both equations, and they both should be true. What's the goal? We want to get our equations into what? Y equals mx plus b. So rewrite. The first one says x minus 3y equals negative 6. I'm going to subtract the x from both sides. So negative 3y equals negative x minus 6. Divide everything by negative 3. And I'm left with y equals, what's a negative divided by a negative? So I have 1/3 x, negative divided by a negative, plus 2. So my slope is 1/3. My y-intercept is 2. It's a positive line. So I'm going to go up 1 over 3, down 1 over 3. Connect my dots. And then I'm going to do my next equation, which is 2x minus y equals 3. Okay, subtract the 2x from both sides. Negative y equals negative 2x plus 3. Can I leave that negative y? No. What should I do? Divide everything by negative 1. In a sense, all you're doing is just changing the signs. But you have y equals negative divided by negative gives me a positive. And then a positive 3 divided by negative 1 is minus 3. So my slope is 2, which is 2 over 1. And my intercept is at negative 3. It's a positive line, so it's going to go upwards. So negative 3, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Draw your line. And where do these two meet? What's that point? At what? 3, 3. Good. Very good. Three more. I want to do 21, 23, 29. Let's look at 21. No matter how it looks, guys, you want to do the same thing every time. We want y by itself. So I have negative 6x plus y equals 4. What am I going to do? Add 6x to both sides? Okay, good. So you have y equals 6x plus 4. What's your slope? 6. What's your y-intercept? Perfect. So I'm at 4, and my slope is 6. So that means I'm going to go down 6. 1, 2, 3, 4, 5, 6. Which way am I going to go? To the left or to the right? If I want my line to be positive. If I come over here and I connect my line, it's going to slope downwards. So I'm going to go over here to the left. And then when I connect my dot, oh, that was brutal. When I connect my dot, so you see how the line, because you read a graph from left to right, that line is going upwards. So now in the second equation, I have negative y, oops, different color. Negative y minus 2x equals 4. What do I have to do here? I'm going to add 2x, good. So you have negative y equals 2x plus 4. Then what? Divide by negative 1. Awesome. Everything by negative 1. So you end up with y equals negative 2x minus 4. Thank you so much. What's my slope here? Negative. That means my line's going downwards, and I'm going to start at negative 4. So I'm going to go up 2 over 1, up 2 over 1, and my line is going to go downwards. When you draw it, you should think to yourself, which way is my pencil moving? Is it moving up or down? Is there a solution to this set of equations? Yes, what is the solution? Where do they intersect, guys? -1, -2. Good. And again, if you check your answer, it takes 2 seconds. You do not have to show me the check or anything like that, but if you check your answer, you can see, oh, yes, I did this right, or no, I didn't. All right, 2 more. 23 I want to do. 23 looks a little different, but that's okay, because what do we want my equation to say? Y equals mx plus b. Does not matter how it's written, you guys can get it there. I'm going to rewrite this as -3x minus 4 minus 2y equals 0, just because I like the 0 on the left hand, or on the right hand side. But I want y by itself, so what do I have to do with -3x and the -4? Or to move them to the other side, right? So we're going to add 3x and we're going to add 4, plus 3x plus 4. So I'm left over here with -2y equals 3x plus 4. Stay with me, guys. We got 2 more. How do I get y all by itself? What's the last thing I have to do? What do I do? Perfect. Divide everything by -2. So y equals -3 over 2x minus 2. This is my slope, and this is my y-intercept. Everything that I'm doing, guys, I'm showing you what I expect to see on your test. This is how you show me your work. You go to -2. You tell me my slope is negative, so it's going to go downwards. So I'm going to go up 3 and to the left 2, down 3 to the right 2. And as I draw my line, I see that it is sloping downwards as I draw. My second equation says 2 minus 1/2 x equals y. How can I rewrite that so the y is on the left-hand side? Perfect. Perfect. Just rewrote it, and y equals mx plus b, slope-intercept form. So my slope here is -1/2. My y-intercept is at 2. So I'm going to go here to 2. My slope is -1/2. Again, it's going to be going downward. So we go down 1 over here, up 1 over here, up 1 over here. Maybe I should have extended my purple line. My slope is 3 over 2, right? 1, 2, 3 over 2. Where do these two lovely lines intersect? Do they intersect? Right there. What is that point? -4, 4. And again, how can I check algebraically that I am correct? Plug it back in. All right, last one, and then I'm going to let you guys go. I want to do 29. Okay, my first equation says -2x equals -8 minus 2y. What should I do? I want it to say y equals. So first thing I'm going to do is add 2y to both sides. So I have 2y minus 2x equals -8. Now what? Not yet, not yet, not yet. Yes, good. We're going to add 2x to both sides. So 2y equals 2x minus 8. Divide everything by 2. Perfect. So y equals x minus 4. My slope is 1. My y-intercept is -4. So go to -4. Your slope is +1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Connect your dots. Okay, second line. I have -2y minus 8 equals -2x. What do I do? I'm going to add 8. Great. So -2y equals -2x plus 8. Now what? Divide everything by -2. So you're left with y equals x, what? minus 4. So my slope is 1, and my y-intercept is negative 4. So I go to here to negative 4, and then I go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, and I connect my dots. What do you guys notice about the purple line and the pink line? They are right on top of each other. What does that tell you? Infinite many. Why is it infinite? I totally agree with you, but why is it infinite? What does that mean? All the solutions. Very good. Anything. I pick this point right here and I plug it in for the x and y. In both equations, it'll work. I pick this point right here, plug it in for x and y. Both equations, it'll work. I plug this point in right here, both equations, what'll happen? It'll work. Good. So guys, if you were to graph, and I know there's an example or two on here, I just don't have the solutions in front of me, so I didn't know which ones to pick. But if I were to graph two lines and I got this, what's my answer? No solution. Why is this no solution? Because they don't intersect. Because your solution is their intersection point. So I will upload this. I just did 9 examples. I will work all of these out, guys, and post them by Thursday. Because some of you asked for extra practice, so it's there for you. Some of you will not look at this again until Monday and then be like, I can't believe we have this hard test. She's so mean. This is way easier than the other stuff. What I told you, we're giving you guys a brain break. So take the opportunity, please. Just make sure you're showing all your work. But I will upload this now.